All right. Welcome back. I'm sorry about the situation this week. I hope everyone's doing well. So this is just temporary. Hopefully the lecture is just the same as it is in person. Understand that there's not enough room to ask questions in this kind of format. But if there's any questions about the lecture itself, please let me know, and then uh, email me those questions, and I'm happy to help. And then when we meet back next week, I'm happy to go over the material again then. All right. Okay, so let's just dive into the material. So we started talking about elasticity and its application last week. And in general, when we're talking about elasticity, in a certain sense, we're talking about price sensitivity, right? So we had a basic setup in mind. Suppose you're a designer for websites and you're charging $200 per website, and currently you're selling about 12 websites per month, right? So what happens if you decide to raise the price of your website from $200 to $250, right? Now, as you can imagine, there is two possible things that can happen. Firstly, the price of the website is being raised, which is to say, on the websites that you do end up selling, you're going to make more money, right? You are selling them for $200 per website. Now you're charging $250 per website. That's a significant improvement. On the other hand, as you raise prices, you might lose customers, right? So the quantity demanded responds poorly to price increases. As we talked about the law of demand, as the price goes up, the quantity demanded for the good goes down. The question then becomes which of these effects is more or less operational, right? In a certain sense, we are asking the question that do I make more money from the fact that the price of the units that I'm selling is higher, or do I lose money on a net basis because I've lost a lot of quantity demanded? And how we try to answer this question is to understand the elasticity of demand itself, right? When we talk about the elasticity of demand, we are trying to figure out what is the effect on the quantity demanded given that one of the determinants of the quantity demanded is changing. In this particular case, when we talk about the price elasticity of demand, we care about what is the responsiveness of quantity demanded for relative to price changes. Right? So, classic example of this. Suppose you start off with a price of P1 and Q1 in this market and you raise prices by 10%. Price goes up by 10%. As a response, the quantity demanded falls by 15%, right? So the price elasticity of demand measures the percentage change in quantity demanded over the percentage change in price, right? So the price is going up by 10%, that's the 10% here, and the quantity demanded is changing by 15%, okay? And in general, it's falling by 15%. So the price elasticity of demand here is the percentage change in quantity demanded over the percentage change in price, which is 15% over 10% or 1.5. Right? One thing to note here that I talked about last class is that if you look at this story here, the price is increasing, so this is plus 10%. The quantity demanded is decreasing, so this is technically minus 15%. So the elasticity is, in general here is negative 1.5. But just for ease, because we only care about the magnitude, we don't really care about the sign, we report the elasticity as positive values, right? So we drop the minus sign and report all price elasticities as positive numbers because we only care about the magnitude itself of elasticity. We don't particularly care about the price itself, okay? So that's where we were last class, right? Now, if you think about how you calculate percentage changes, the first thing is that you look at the end value, subtract the start value, so that's the change, over the start value times 100%. That's how you calculate percentage changes in general, that you use end value minus start value over the start value times 100%. Right? So for instance, if I go from A to B, point A here to point B here, if I look at the percentage change in price, the initial price, the start value is 200, the end value is 250. So if I look at the percentage change in price, it's the end value 250 minus the start value 200 over the start value, which is 200, right? So this tells me that this is 25%. Okay, so price is going up from 200 to 250 is a 25% change in prices. Similarly, when I go from A to B on the quantity side, the quantity starts at 12 units, ends up at 8 units, so the end value is 8, the start value is 12, so the percentage change in quantity is 8 minus 12 over 12, or negative 33%, right? So if I look at the price elasticity here, is the percentage change in quantity 33 over the percentage change in price 25. So I get a price elasticity of 1.33 when I go from A to B. All right, that's the standard way of computing percentage changes. You do end value minus start value over the start value times 100%. Okay. But the trouble is when we go from B to A, right, instead of going from A to this point B, suppose we go from B to this point A, right? So if I go from B to A, the percentage change in price is now the start value is 250, the end value is 200, and the start value is 250. So if I take this difference, 200 minus 250, so the end value is 200, the start value is 250, so that's negative 50 over the start value, which is 250, I get a percentage change of negative 20%. Similarly, when I go from B to A, the percentage change in quantity is 50%, right? So B to A is start is 8, end is 12. So the difference is 12 minus 8 is 4 over the start, which is 8. So that's 50%. So if I look at the price elasticity here, which is the percentage change in quantity over the percentage change in price, I get 2.5, right? And that's the trouble, right? If I go from A to B, the price elasticity is 1.33, but if I go from B to A, the price elasticity is computed as 2.5, because as you can imagine, with percentage changes, it really does matter what's in the denominator here. Where you're starting is going to matter, right? Because the percentage changes is just measuring relative changes to start value. It does end up mattering with where you start, okay? But as far as we are concerned, with elasticity, the point is that when we go from A to B or B to A, it shouldn't really matter to the elasticity itself. The slope itself shouldn't really change, because that's what in essence we're measuring. The gradient here on this line from A to B shouldn't really change. And so that's the problem with computing elasticities using the standard method of computing percentage changes. Right? I hope that's clear. Okay, so how do we get around this issue, right? That seems like a issue and we need to get around it. So let's talk about how to get around it. One way we get around it is to basically talk about the midpoint method, right? So if you go back to the previous slide, it says in the denominator here we have the start value, right? And the number is changing based on where we are starting and where we are ending, right? So to avoid that, we set that at the midpoint, right? So what this allows us to do is basically look at the end value minus the start value, but now it's not sensitive to where you start, right? We'll just take the midpoint of these two values, which is Q2 plus Q1 over 2, so the average of these two values, that tells me where the midpoint is. So this allows us to start from the same basis of comparison and compute percentage changes, so it's not as sensitive, right? So in a particular example, if you use this method, if I look at the midpoint of prices here, 200, 250, the midpoint is 225, right? So if I compute the percentage change in price when I go from A to B or B to A, so in this particular case, I'm going from from A to B, the percentage change in price is that I end at 250, I start at 200, but instead of using the start value here, I use the midpoint of those two values, right? So 250 minus 200 is a 50, and the midpoint is at 225, and that tells me it's 22.2%. Similarly, percentage change in Q, if I go from A to B, right? If I go from A to B, then the end value is, or from B to A, then value is 12, the start value is 8. But now instead of using the start value in the denominator, we use the midpoint between these two values, which is 8 plus 12 over 2 or 10. That's the midpoint, right? So the percentage change in quantity here is 40%. So if I compute price elasticity this way, the percentage change in quantity or the percentage change in price, it gives me 1.8, right? This measure of price elasticity is not sensitive to what the start and end values are. It doesn't really matter whether I go from A to B or B to A, which I use as start and end values. It is always going to give me the same answer. The price elasticity doesn't change based on where I start and where I end. And that's the crucial element of why we want to use something like this to calculate these percentage changes in price elasticities, because we want a measure which is not sensitive on where the start values and end values are, and the midpoint is not sensitive to where the start and end are, right? In a intuitive sense, the midpoint doesn't really care what the start and end are, because the start and end to the midpoint calculation are basically weighted the same way. Right? So that's basically one crucial thing to recognize, is that when you're calculating price elasticities and percentage changes, that you use this midpoint method so as to get consistent answers. Whether you go from point A to point B or point B to point A, you get the same answer. Right? Okay, so I hope that makes things clear. Again, just pick up a piece of paper and actually run the math yourself, do the calculations that I've done here yourself, and you'll see what I'm talking about, right? So you can, the example itself is here. In class, I would have shown it to you on a whiteboard, but you can just pull out a piece of paper and do the calculations, and it would make sense that the price elasticity now doesn't really change based on where we start and where we end, right? Okay, so let's take an example, right? Let's talk about calculating an elasticity. So we have the following information to calculate the price elasticity of demand for iPhones, right? So when the price is $400 of an iPhone, the quantity demanded is 10,600 units. And when the price is $600, the quantity demanded is now lower, obviously, it's 8,400 units, okay? Now we want to calculate what the price elasticity of demand for iPhones is, right? Remember, when we're talking about price elasticity of demand for iPhones, we care about the percentage change in the quantity demanded for a percentage change in the prices, right? Okay, so let's use the midpoint method here to calculate the price elasticity. Okay, so the percentage change in price, right? The price changes from $600 to $400 as this change in price over the midpoint of these two prices. The midpoint of 600 and 400 is 500. So the percentage change in price relative to the midpoint is 40%. Okay. Similarly, the percentage change in quantity demanded, the percentage change in the quantity changes from 10,600 to 8,400 over the midpoint of these two quantities, right? The midpoint of these two quantities is 9,500. How do I get to that midpoint? I add these two numbers up, 10,600 plus 8,400, that's 19,000. Divide that by 2, I get 9,500, right? So the percentage change in quantity demanded is 23.16%. So when I calculate the price elasticity of demand, I take the percentage change in quantity demanded for the percentage change in price, and that tells me that the price elasticity of demand in this case is 0.58. Okay. All right. So that's how we use the midpoint method to calculate price elasticities. And remember that we use the midpoint method because the measure of price elasticity will change based on what is the end value and what is the start value. So in order to control for that, we use the midpoint method. Instead of being dependent on what the start value and end values are, we just look at the midpoint of the start and end values and use that as the common basis for analysis. Okay. All right. Hope that's clear. Okay. Okay. So let's keep going with the material. All right. So the price elasticity of demand. We look at a few examples here, right? Comparing two common goods. Suppose the price of both goods changes by the same percentage, right? Suppose prices of both goods rise by 20%, right? What we expect to see is that depending on what the good itself is, there should be differences in the percentage change in quantity demanded. Not all goods quantity demanded is going to change the same way for the same increase in prices. For some goods, for a 20% increase in prices, the change in quantity demanded might be a lot. For a certain class of goods, it might be very small, right? So that's what we care about, and we'll talk about a few examples of this, right? So here's one example, right? Breakfast cereal versus sunscreen, right? These are the two goods we are comparing. Prices of both goods have risen by 20%. We want to know what is the percentage change in quantity demanded for each of these goods, and which do we think will be greater, right? In the first instance, if you think about breakfast cereal, there is a lot of varieties out there. So if you go into your grocery store, you're going to see tens, if not hundreds of varieties of cereal which is available. So if the price of one particular cereal goes up by 20%, you have close substitutes which are available, right? Unless you have a really strong choice for the cereal, you're price sensitive, you don't really care among the different kinds of cereal, so you choose the cheapest one, right? So if the price of one particular cereal is raised by 20% and there are close substitutes available for that particular cereal, the change in quantity demanded is going to be a lot, right? Because there's a lot of close substitutes, you just stop buying that cereal for which the price has gone up and buy a lot more of the other cereals which are available, right? So when close substitutes are available for a good like breakfast cereal, the price elasticity is higher. Similarly, if you think about sunscreen is sunscreen, right? Like if you go into the store, the price of sunscreen has gone up by, the price of sunscreen has gone up by 20%. What choices do you have, right? There are no close substitutes which are available for sunscreen. The price elasticity is going to be relatively low, right? Again, in an informal sense, price elasticity of demand is measuring price sensitivity, right? So if the price goes up for cereal, there are other close substitutes available, so you buy the cheaper alternatives, right? So the price elasticity is much higher in the presence of close substitutes for a particular good. In the case of sunscreen, there are no other close substitutes, so if the price goes up and you need sunscreen, you don't change your behavior by a whole lot, right? So this is the first clear case when we are comparing two goods. The good with the with more close substitutes will have a higher price elasticity in demand relative to ones which don't have close substitutes. Okay, that's the first thing to recognize. The second example, blue jeans versus clothing, right? This is basically a comparison between goods which are narrowly defined and goods which are broadly defined, right? If you think about blue jeans, it's a very specific, narrowly defined good, right? If the price of blue jeans goes up by 20%, you want blue jeans, the price has gone up by 20%, and it's a very narrowly defined good. It's not a broad category of good, so the price elasticity is going to be fairly low, right? The price elasticity is higher for narrowly defined goods in a sense that you're going to basically look at blue jeans and you say, okay, the price has gone up, but there are many different kinds of blue jeans which are available. There's a lot of close substitutes which are available. So when it's a narrowly defined good, it's easier to find close substitutes for narrowly defined goods, right? So when the category is narrowly defined, the underlying that is the assumption that to this narrow category of goods, there are close substitutes which are available. And so what you find is that when the price of narrowly defined goods goes up, the price sensitivity is a bit more. The price elasticity is higher. Versus clothing, right? Like when I define a broadly defined category like clothing, what is the close substitute for clothing, right? It doesn't really uh, come to mind intuitively what a close substitute for clothing is. So you buy clothing, or what is the alternative, right? That's what we mean by substitute, or what is the alternative. So this is the case when the category of good is broadly defined, the price elasticity is going to be lower, right? So for a narrowly defined goods, the price elasticity is going to be higher than for broadly defined goods, right? That's the second kind of comparison. The third thing is about luxury goods, right? And necessary goods. It's basically the difference between necessities and luxuries, right? Consider the situation between insulin and yachts. Okay, insulin is a life-saving drug, right? You need to take it in order to manage diabetes, and you can't not take it, right? It's life-threatening if you don't take the right dosage of insulin. So if the price of both of these goods goes up by the same percentage, right, 20% increase in prices of both. Now, insulin is a necessity, right? It's a necessary good. People have to buy it. So when the price goes up, if it's a necessary good, you have nowhere else to go. You need that good, so you're willing to swallow the higher prices. So your price sensitivity, price elasticity, or price sensitivity is going to be lower for this kind of a good. When it's necessary, and you're willing to absorb higher prices because it's a necessity. So the price sensitivity of demand to an increase in prices of necessary goods is going to be lower than for luxury goods. For instance, yachts, right? If the price of a yacht goes up by 20%, it's not a necessity. I don't need a yacht. And it's gotten more expensive. So the elasticity of demand is going to be higher for luxuries, right? I'll respond by cutting back on my purchases of these luxury goods a lot more than I would do on necessities, right? So the third kind of comparison between goods along the lines of elasticity is between necessities and luxuries. Okay, and intuitively it should make sense. It should make complete sense that if it's a necessary good, the price goes up by 20%. I still need it at this higher price. I don't cut back my demand by a lot. On the other hand, if it's a luxury good and the price goes up by 20%, then I look at it and I say, all right, at these higher prices, I don't really need this good, and I can cut back on my demand for this good by a lot. Right? So that's what price elasticity is saying, is that price elasticity should be higher for these kind of luxury goods than for necessities. Okay. All right. The fourth category, the short run versus the long run. Right. Again, intuitively, if you think about it, it's much easier to adjust for price increases in the long run than it is in the short run, right? In the short run, you don't really have too many options. You can't really change behavior too much in the short run. For instance, consider gas prices in the short run versus the long run, right? So the price of gas goes up by 20%, right? Okay. You still need your car to get to work. You still need to buy gas. It's more expensive today. What are you going to do about it, right? You can't do much about it. So the price sensitivity or price elasticity is not that high in the short run. In the short run, you just absorb the price blow and then cut back on your quantity demand. And maybe you need 5 gallons. You would have bought 5 gallons regularly. Prices go up by 20%. Maybe you just buy 4.5, right? You can adjust a little bit, but not a lot in the short run, because adjustments take time. You need to adjust to the new price reality and make those changes over the long run. So in the long run, if the prices continue to stay high, if the price of gas continues to stay high in the long run, then that gives you sufficient time to adjust to the fact that price for gas is higher in the long run, and you can change your behavior. You buy smaller cars, you move closer to work, you consider buying an electric car or a hybrid car, something which is cheaper to run. You can make all of these changes, but you can't make them overnight. So that's basically what we're talking about. A short run price sensitivity is not very high, right? You can't do much in the short run, but in the long run, it gives you enough time to change behavior and move your quantity demanded a lot more, right? So when we think about price elasticity, we expect it to be higher in the longer run than it is in the short run, okay? Again, intuitively, I hope that makes sense, okay? All right. Okay, so let's keep going, okay? So let's talk about the different varieties of demand curves. Okay? So we'll talk about three basic categories of demand curves. Right? Demand is said to be elastic, right? If the price elasticity of demand is greater than 1. Right? Demand is said to be inelastic if the price elasticity of demand is less than 1. And the demand curve is said to have unit elasticity if the price elasticity of demand is exactly 1. Okay? What does it mean in practice? Intuitively, what this means is that if prices change by 10%, the percentage change in quantity demanded is more than 10%, right? That's what it means for the price elasticity of demand to be greater than 1. What it means is that if the price rate is of a good is raised by 10%, the quantity demanded of that good falls by more than 10%, right? So that is to say, people are very price sensitive. Demand is elastic, which is to say increases in prices result in big decreases in quantity demand. Demand being inelastic is a case where the price goes up by 10%, but demand falls by less than 10%, right? This is a case where the quantity demanded, the cutback in the quantity demanded is lower in percentage terms than the increase in price, so it's less than 10%. Okay? Unit elastic is just one to one, right? If the price of a good raises by 10%, the quantity demanded of the good falls by 10%, and you get a price elasticity number of 1. Okay, so let's see this in example. Okay, so we'll consider the limiting cases, the cases where demand is perfectly inelastic, where demand is perfectly elastic, and we'll see what curves come out of this, what kind of demand curves come out of this. Okay, all right. So let's consider the first case, the price elastic in perfectly inelastic demand, right? This is a case where the prices can go up and go down, but basically the quantity demanded for the good doesn't really change, right? Okay, to be perfectly honest, in the real world it's really hard to find goods which are perfectly inelastic, right? This is a case where what it says is that if the price is $10 or the price is $1,000, your quantity demanded for that particular good doesn't change. It is fixed. It's Q1. It stays at Q1 and doesn't really change, right? So in this particular case, the price falls by 10%, but the change in quantity is zero, right? There is no change in quantity. You were buying Q1 when the price was P1, right? When the price was P1, you're still buying Q1. When the price is P2, you're still buying Q1. The prices have gone down by 10%, but the percentage change in quantity is 0%, so the price elasticity is 0. Okay, so this is a case where the demand curve is vertical, right? It's perfectly straight line vertical, and consumers' price sensitivity is none. There is no price sensitivity at all. The prices can go up or go down. The consumer still buys the same quantity of that good as they were, right? So in practice, in reality, it's hard to find goods which satisfy these conditions of having perfectly inelastic demand, but you can consider cases where it gets pretty close. For instance, life-saving drugs, right? A cancer treatment, uh, if it costs $10, you don't rush out to buy more of this drug, right? The cancer drug. Just because the price is low, you just don't go out of your way to go buy a lot of this good. When the price is really high, like $1,000, you don't cut back on, if you need it, you don't cut back on how much you purchase because you need it and you're willing to pay the high price, right? So in some cases, some particular classes of goods, we can get very close to having perfectly inelastic demand, but in general, it's really hard to find goods like this. But the crucial thing to recognize here is that the price is changing, but the quantity, it's not, right? That's what it means to have perfectly inelastic demand. The percentage change in quantity is strictly 0% for any percentage change in price, right? So this generates a demand curve which is vertical, where the quantity is self-fixed and the prices can vary as much as it wants, but the quantity demanded doesn't change. It stays where it's at. Okay. All right. This is a more general case, inelastic demand, right? So suppose the price starts at P1 and Q1 for this good, and the price falls by 10%. Okay. If the price falls by 10%, the quantity demanded rises in this particular good by less than 10%. Right? This is a case where the demand is inelastic, which is to say the percentage change in price is 10%, but the percentage change in quantity is less than the percentage change in price. Right? So imagine that gas prices go down in the short run. Right? So there is some kind of decrease in gas prices. In the short run, what can you really do about it, right? Yeah, one, you pay less at the pump, but you're not going to buy extraordinarily more amounts of gas just because the price is lower. For the gas that you already buy, to fill up the tank on your car is going to cost less, but you don't expect to increase how much you purchase of gas that much, right? You might say, oh, okay, the price is low, so I might get a few jerry cans, fill up on gas, maybe store them, but that's a small change in quantity demand, right? The price is falling by 10%, but the quantity is changing by less than 10%. This is a case where there is inelastic demand. There is relatively low price sensitivity. So if you look at this is less than 1, right? This is going up by 10%. This is falling by less than 10%. The change in the numerator is less than the change in the denominator. So the price elasticity of demand is less than 1. Okay. So what you get is a relatively steep demand curve, right? This is, if you look at the slope of this curve, it's relatively steep. This essentially says that the price sensitivity of the customer is fairly low in this market, right? The price falls by 10%, but the quantity doesn't change by the same magnitude. It changes by something less than 10%. This is a case where we have what we call inelastic demand. Okay. All right. Unit elastic is the middle ground. It's an intermediate case. So price goes down by 10% and quantity goes up by 10%, right? So the percentage change in price is exactly equal to the percentage change in quantity. So if I take this ratio, this is always going to be equal to 1. This is what we call a unit elastic demand, right? There's basically a one-to-one relationship between the percentage change in price to the percentage change in quantity. The elasticity for this good, the price elasticity of this demand for this good is exactly equal to 1. Right? Price falls by 10%, quantity rises by 10%, so the price elasticity is exactly 1. Okay? All right. Elastic demand, as you can imagine, this is the next case. The demand curve, as you can imagine, is getting flatter and flatter. So we started with a vertical one, then we started with a very steep one, then we started with an intermediate slope one, and this is getting flatter. So this is a case where the percentage change in price is 10%, price falls by 10%, but quantity rises by more than 10%. Right? Okay. So this is a case where if price falls, consider durable goods, right? Something which can last for a long time, that you can buy in bulk and store. Okay. For instance, our example of cereal. Cereal has a very long shelf life, right? You can buy cereal and put it on your shelf for a long time and then still be able to consume it. So if the price for your favorite cereal goes down, you end up increasing the demand for that good by a lot, because you buy it at this now lower price and then you store it for a long period of time, so you can enjoy you can lock in this low price for a long period of time, right? This is a case where the price has fallen by 10%, but the percentage change in quantity is more than 10%, right? There's a bigger response on the quantity demanded side relative to what the percentage change on the price is. This is a case where we have what we call elastic demand, right? The price sensitivity here is greater than 1, the price elasticity is greater than 1, and the price sensitivity is relatively high. Okay. All right. The last case is when we talk about perfectly elastic demand, right? So this is where there are very, very close substitutes available. This is what we call extreme price sensitivity, right? So if the price rises or falls by any small amount, the demand for that good basically goes to zero, right? Okay. Sticking with the cereal example, right? So if you go into your local grocery store, the next time you do, try to observe this. All the box cereal is basically priced at and around the same price, right? There's small differences, but between 450 and $5, you're going to find most of the cereals are priced in that range. Why should this be the case? Because customers are extremely price sensitive. People don't have very strong preferences on what kind of cereal they consume, right? They look at prices, they'll choose the one that they like, and they're off, right? So if you try to raise prices in this kind of environment by even a small amount, customers will respond by basically buying nothing of your good and buying more of your competitor, right? So you can survive in this market by setting prices at P1. If you try to change prices, the entire market moves away from you, right? So this is a case where price changes by 0% and quantity can change by any amount, right? So the price cannot change. Is basically in a simpler way, a perfectly elastic demand for a good means that the price can't be changed, right? If you change the price, the entire quantity, the percentage change in quantity is really, really dramatic. This is a case where the price elasticity is infinite and consumers' price sensitivity is extreme, and you get a horizontal demand curve, right? So if we go back, when we talk about a perfectly inelastic good, it has a vertical demand curve. As the curve gets flatter and flatter, the demand gets more and more elastic, right? The price sensitivity starts to rise as the demand curve gets flatter and flatter. In the limiting case, the demand curve is perfectly horizontal, in which case you generate perfectly elastic demand. Okay, so that's the different varieties of demand curves that you can generate using price elasticities. Okay, so here's a classic example of you can compute price elasticities for different kinds of goods, and here we have some. For instance, think about eggs, right? Eggs don't have close substitutes, right? You can buy different kinds of eggs, but if you want eggs, there's eggs. You don't buy, there's no substitute, there's no close substitute that you buy instead of eggs, right? So in this particular case, the price sensitivity is relatively low. I can raise prices by a small amount without losing a lot of quantity demanded, that because where do my customers go, right? If they want eggs, they have to pay the higher price for eggs, and so you're going to have reasonably inelastic demand in this market, because basically there is no close substitutes for this. Similar story with healthcare. So the number here is small, suggesting that the demand is relatively inelastic. Healthcare, again, the same story, right? If you need healthcare, the prices of healthcare go up. You still need healthcare and it's necessity, and there's no close substitutes for healthcare. You still need to access this good, and your price sensitivity is going to be very low, right? Similarly for cigarettes, you're addicted to any kind of drug or any kind of good which has these addictive properties. They usually have very low price sensitivities or low price elasticities, right? But on the other end, here you can see that goods where, like for instance, Mountain Dew, soda of any kind, right? There is a plethora. There's many different kinds of sodas available on the market. And if you look through the grocery store, you find that the prices of all different kinds of sodas basically set at the same level, right? Because if Mountain Dew tries to raise the price of its drink by a small amount, customers look at that and say, I don't really care about just having Mountain Dew. If Mountain Dew costs, I don't know, $2.25 for a 6 pack, and let's say Sprite costs $1.99, I don't have a strong enough preference for Mountain Dew that I'd spend the extra 25 cents buying Mountain Dew, right? Then I just buy the cheaper soda and go home, right? This is a kind of case where the presence of and availability of close substitutes means that price sensitivity is really, really high, right? Similarly for restaurant meals, peanut butter, the more substitutes that are available, or in a intuitive sense, the more competitive the market is, the more price sensitive the demand for a good is, right? If there's a lot of competition inside a market, you can't change prices by a whole lot without losing a ton of demand, right? That's basically what the story is. Okay, all right. I hope all of this is clear. I hope the lecture itself is clear. And if there's any questions, shoot me an email, or when we're hopefully back in class next week, I'll be happy to answer these questions. Okay. Okay. So let's keep going. So let's talk about price elasticity and total revenue. Okay. So the story here is, let's go back to the original story, right? You are designing websites and you want to raise prices from 200 to 250. The question is, would your revenue rise or fall, right? Does the amount of revenue that your firm collects, will it go up when you raise prices, or will it fall? And the answer to this question basically depends on price elasticity. Okay, so before we get into that, let's talk about what we mean by total revenue. Total revenue is just price times quantity. Right? This is the price at which you sell each good. This is the number of units of this good that you're selling. So the price times quantity tells you the dollar value of the goods that you've sold. That is what we call total revenue. Okay. If you think about what effects a higher price has on total revenue, there's two competing effects. Okay. If I raise prices, right? If I raise prices, on the one hand, on the units that I sell now, I can make more money, right? The price, higher revenue, because there's a higher price per unit. I'm selling you each unit at a higher price. That has a positive effect on revenue, right? I can increase my revenue that way. But if I increase my prices, the quantity demanded, because we know the law of demand tells me that it's downward sloping, that as prices go up, the quantity demanded falls. I have a second effect which takes place, which is that you sell fewer units at higher prices. As you raise prices, you sell fewer units. Now the question comes down to, is the percentage increase in price greater than the percentage change in quantity demanded? If that is the case, then the price effect is more dominant. That you might end up with higher revenue because the percentage change in price is greater than the percentage change in quantity. Okay, so all this entire question on what the effect of a price change on total revenue is going to be is basically answered through the channel of asking the question, what is the price elasticity of demand, right? What is the price elasticity of a demand for this particular good? Okay, let's see two examples, right? We'll get to the examples themselves, but here's what the basic intuition and the theoretical underpinnings are. Okay, if for a price increase, if the demand is elastic, right? Elastic is to say that the demand is very price sensitive. So if you think about when demand is elastic, the percentage change in quantity is going to be greater than the percentage change in price because the elasticity is greater than 1. It's an elastic demand, which is to say that people are very price sensitive in this market. So the percentage change in quantity is going to exceed the percentage change in price. So whatever additional revenue that you can earn by increasing the price is going to be offset by the loss in the number of units that you're able to sell at these higher prices, right? This is a case where the total revenue decreases because the fall in revenue from the lower quantity that you're going to sell exceeds whatever higher revenue that you're going to increase in revenue that you're going to get from the increased prices. Okay. So if it's not that particularly clear just yet, hold on, we'll go through an example, and I hope that that makes things clear. Okay. Uh, Similarly, the other case is that if the demand is inelastic, right? Basically, price sensitivity is fairly low in this market. So elasticity is less than 1. So the percentage change in quantity is less than the percentage change in price, right? This is a case when the total revenue should increase, right? Why should it increase? Because the fall in revenue from selling fewer units is less than the increase in revenue from charging higher prices, right? This is a case where net effect the total revenue goes up. Okay, all right. If this is not completely intuitive or clear just yet, let's take a look at an example, and this should make sense. Okay. Okay, so we have a demand curve for the websites, and it's fairly elastic. Okay, so suppose initially you were selling 200, the price per unit of website was $200, and you were selling 12 units, right? So if I think about the total revenue, it's this area of this rectangle here, right? This is price, right? This is the height. Is essentially the length of the rectangle is 200. The breadth is 12, right? So price times quantity. So this area of this rectangle represents the total revenue, right? So in this particular case, the total revenue is $200 per unit. 12 units are sold. The revenue is $2,400. Okay. So suppose I raise prices to $250, right? I raise prices from 200 to 250. As a consequence, the quantity demanded for websites falls from 12 to 8. Okay. So if I think about the total revenue that I generate right now, it's $250 per unit. 8 units are sold, so 250 times 8, the total revenue now is $2,000, right? Earlier, When the price was set at 200, I was making 2400. Now when the price is set at 250, I'm making $2,000. There's a decline in revenue when I've increased prices. Why is this the case? This is the case because the decrease in quantity demanded is very profound because the demand is fairly elastic. Okay, one way to see this is that there's two effects which are here. When I raise prices from 200 to 250, I lose sales of, I move from selling 12 units to 8 units. So there's 4 units worth of sales which have gone down. Initially, I was selling each of those units, websites for $200 a pop. So I've lost 4 units worth of demand, which were generating $200 a pop. So I lost $800 by losing these customers. Right? By losing these 4 customers, I've lost $800. But on the other hand, if I look at this particular rectangle here, all the 8 units that I'm now selling at the new prices are all making more money. Instead of selling them for 200, I'm selling them for 250, which is to say this is $50 per extra that I'm charging per website, and I'm selling 8 extra websites. So my increase in revenue from the higher prices is $400, but my decrease in revenue from losing customers is $800. In net, I'm making $400 more by increasing prices, and I'm losing I'm making $400 more by raising prices, but at the same time losing $800 because the quantity demanded has gone down because I've raised prices. In net, this is a decline of $800 in revenue. This rectangle represents an increase in revenue of $400. If I net these two rectangles out, I've lost revenue of $400, and that's what's being reflected here, right? Because the demand is elastic, right? Because the demand itself is elastic, what we find is that when I raise prices, the loss in revenue from the change in quantity demanded swamps whatever increase in revenue I get from raising prices, right? So this is a classic example of when there is a lot of competition in a particular market, you try to raise prices. In a certain sense, you might make more revenue in this direction, but you might lose a lot of customers. And in net, if I take a look at both of these rectangles together, what the net effect is, I end up with a lower revenue triangle, lower revenue rectangle. Okay, I hope that makes sense. But let's talk about the second case, right? Inelastic demand, when the elasticity is fairly low. Okay, so initially I was selling $200 worth of websites, $12 a pop. The revenue I made was $2,400. Everything stays the same. And now I decide to raise prices by 250. I raise prices by $50. And instead of selling 12 units that I was before, now I sell 10 units. Right? If I look at this, I've actually increased revenue by increasing prices. Right? This is a case where initially I was making $2,400, but I raise prices and I make more money. Okay. One intuitive way to think about the story here that we are telling is asking the question, if I raise prices, how many customers do I lose? Right? That's what we're trying to answer. Okay. If the number of customers I lose, or if the percentage change in quantity demanded in a formal way is relatively low, that's good news, which means that I can raise prices and not lose a lot of customers, right? That's what it means to have inelastic demand. So that's what's happening in this case, right? So I lost 2 customers. I was making 12 websites, now I'm making 10. So I've lost 2 websites. I was making $200 for each of those websites. So I've lost $400 in revenue here. Okay. So that's a $400 loss in revenue because I've lost 2 customers who are each paying $200. But the now remaining 10 customers are each paying $50 more than they were before, right? I've lost 200 here, but each of the remaining 10 customers that I've left are paying $50 more. So 50 times 100, 50 times 10 is 500, right? So I'm increasing revenue by 500 by charging higher prices to the remaining customers, while I've lost $400 by losing two customers who don't want to pay the higher prices. In net, I've raised revenue here to 500, I've lost revenue of 400. In net, the net effect, if I take into account these two rectangles here, the net effect is that I've increased my revenue by $100, and that's what's reflected here. Okay. So when the demand is inelastic, which is to say when the price sensitivity is relatively low, you can raise prices and increase total revenues, right? You have the ability to raise prices without losing a lot of without losing a lot of customers, which is to say when you increase prices, you're able to raise revenue. Okay. All right. Okay, so we'll finish up the session with an example, right? Pharmacies raise the price of insulin by 10%. We want to consider two kinds of cases, and we want to know whether total revenue rises or falls. Okay. Here's the first case. Pharmacies raise the price of insulin by 10%. Okay. Does total expenditure on insulin rise or fall? Okay. The first question to ask is, what is consumers' price sensitivity to insulin? What is the price elasticity for insulin? Insulin is a necessity. Okay. So if the price goes up by 10%, you can't really respond by cutting back on how much insulin you buy, right? This is fairly inelastic demand in this case, right? Because if you raise prices by 10%, your customers, in this case patients who need insulin, they continue to need insulin because it's a necessity, and so they're willing to pay the higher prices, right? So this is a case when you will have inelastic demand. So demand is inelastic, so the change in quantity is going to be, the percentage change in quantity is going to fall by less than 10% for a 10% increase in prices. So this is a case where you can increase your expenditure or total revenue by raising prices because the demand is relatively inelastic, right? Because the demand is inelastic, you have some level of pricing power in this market, because if you raise prices, you're not going to lose a whole lot of customers. You raise prices by 10%, your quantity demand will fall. Some people will start rationing their insulin or making other accommodations and stuff like that. So the quantity demanded will fall, but it'll fall by less than 10%. So this goes up by 10%, this falls by 10%. So in net, the total revenue is going to go up, right? The price effect is more dominant than the fall in quantity demanded effect. Okay. Second example, right? Result of fair what? Price of luxury cruises falls by 20%, right? So if you think about luxury cruises, they are not necessities, these are luxury goods, and the price of a luxury good has fallen by 20%, right? Does the luxury cruise company's total revenue rise or fall, right? Okay, so the question is, revenue is again price times quantity, okay? Now the question is, if the price falls by 20%, what is the percentage change in quantity demanded? Is it more than 20%, less than 20%? Okay. The fall in price is going to reduce revenue. But because now cruises are cheaper, more people, the quantity demanded for cruises is going to increase. But Q increases, which should increase revenue. The question is, which effect is bigger? This is a case where demand is fairly elastic, right? Because this is a case where price sensitivity is fairly high. Luxury cruises are quite expensive, and I have a temporary sale where the prices have gone down by 20%. A lot more people are willing to take a cruise when the price has fallen by 20%, right? So the percentage change in quantity demanded we expect to be greater than 20%. This is a case where the demand is fairly elastic. So the fall in prices is 20%, but the increase in quantity demand is more than 20%. The increase in quantity demanded will offset whatever is happening on the price side of things, and overall the total revenue should rise. Okay, that's kind of the intuition, right? Okay. All right. I hope that makes sense. The last thing This is again a very interesting piece of research. Um, we'll talk about this example and then we will basically stop for today. Okay. So the on drugs, basically, there were two different policies that were considered, right? So one thing is that, okay, so you can increase drug interdiction. Interdiction, just a fancy way of increase drug bust on a street level. More number of federal agents are deployed, and you basically try to take supply off the street, right? So there's illegal drugs, and you're going to spend your resources on hiring more and more federal agents who patrol the streets, who conduct more street level busts, and try to decrease the supply of this. Uh, good which is available in the market. The question is, does this work, right? Does it, uh, what happens, what is the effect of this policy on drug related crimes? Okay, so imagine how you would go about analyzing the situation. Okay, so there's a supply of drugs, S1, it's the illegal supply of illegal drugs, and D1 is the demand for drugs. Okay, now, if you look at D1, it's fairly steep, right? Fairly steep demand curve basically is reflecting the fact that the price elasticity or price sensitivity on the demand side for drugs is fairly low, right? Drugs cause addiction. When you're addicted to a particular kind of drug, you don't really care about the price, right? Price goes up, you still need it, and your price sensitivity is really, really low. Okay, that's what the demand for drugs is reflecting. The fact that this is very, very steep, the demand curve here is really steep, is reflecting the fact that the price elasticity for illegal drugs is fairly low, right? Okay, so demand meets supply. That tells me what the equilibrium quantity for the price for this drug is, and the equilibrium quantity is price times quantity tells me revenue. So this is the initial value of the drug related crime. Okay, fine. I implement a new policy, right? I say, okay, there's going to be more agents on the ground. They're going to try to remove more supply of the drugs off the street, and the policy has the desired effects, and the supply curve shifts from S1 to S2. So we shift the supply curve from S1 to S2 because there's more bust being made, more supply is coming off the market, and that's what's happening. So now the new supply curve is at S2, the demand is where it's at D1. So if you think about the new equilibrium, the price will be at the intersection of the demand curve D1 and the new supply curve S2. So there is a new equilibrium in this market. So price goes up from P1 to P2, while quantity goes down from Q1 to Q2. Okay. And as you can imagine, the demand for drugs is fairly inelastic, right? And that's what's being reflected here. If you look at the change in price, the price change is massive, right? The price change is a big change, right? You're taking a lot of drugs off the street, the price increase is really, really high. The quantity demanded, on the other hand, doesn't fall by as much, right? Because the drug is addictive, people want this, so you have this problem on your hands. So that's what's happening, right? If you think about the total revenue, right, total value of drug related crime, it basically has gone up. You've reduced this amount, right? This little rectangle is the decrease in the value of drugs available in the market by your actions, but at the same time you've increased the amount of revenue that can be generated because the price per unit of this drug has gone up a lot more than the quantity demanded for this drug has gone down by, right? All you've managed to do by moving the supply curve here is basically made the price of the drug skyrocket without altering how much demand there is for this drug, which makes this industry even more lucrative, right? So there is an increase in the spending on drugs and in drug related crime. As the industry itself just starts to generate higher and higher revenues, you're going to basically get a spike in the crime rate. Right? So that's one policy. So you try to do drug interdiction, which is to say you try to take drugs off the street by deploying more federal agents and trying to shift the supply curve. And what do you get? you get higher prices for the drugs which continue to be sold. Like unless you're able to shift the supply back to zero, where there is no supply at all, right? Unless you're able to basically take all the drugs off the market, whatever remaining drugs there are still left on the market all get sold at much higher prices, and there's not going to be a big change in the quantity demanded because yeah, the prices are higher, but it's an addictive substance, and people still find ways to get to this drug, right? So if this is increase in crime rate because it's such a expensive drug, people still need it, so armed robberies and stuff like that go up, right? That's what we see in the empirical data as well, right? So the second policy could be drug education, right? You could try to basically educate people on the consequences of consuming drugs. You try to reduce the demand for illegal drugs, right? So again, the basic setup is the same. This is the demand curve, which is relatively steep. The supply curve, initial supply curve. Equilibrium determines what the price and quantity are, and P1, Q1 tells me the value of the total revenue that you can earn from this drug-related crime. Okay. Now you try to educate people, try to give them resources, try to put them through rehab, try to do all of these things. So you can try to reduce education through education the demand for drugs. So if you move the demand curve from D1 to D2, and the supply is where it's at, there's nothing is altering the supply curve. So what happens in the new equilibrium, the D2, which is the new demand curve, meets the original supply curve, and the new equilibrium is at a lower price and at a lower quantity, right? So if I think about the new value of drug-related crime, it's this new smaller rectangle, right? So P2, Q2, which is there's a decrease in the total amount of spending on drugs and in drug-related crime, and you basically have the desired effect, and because you're pushing in both directions. The price is coming down not because the price is coming down primarily because fewer people are out there trying to get to these drugs, and as a consequence, the quantity demand is also falling at the same time. All right. So the punchline here is, of course, that the basic setup is fairly straightforward, but using just a basic setup, you can get to fairly interesting places. Right? Okay, so we'll stop there for today. I hope this was useful and convenient. Hopefully, I'll see you next week. Take care and good luck.